Question number 1. State whether the following statements are true or false. First one. Every irrational number is a real number. That statement is true. What is the reason? Real numbers are the collection of rational and irrational numbers. Real numbers are the collection of both rational and irrational numbers. Of rational and irrational numbers. We know that real number system, here real numbers, and it can be divided as rational numbers and irrational numbers. Rational numbers and irrational numbers. So the first statement, every irrational number is a real number. Correct. Every irrational number is coming under real numbers. So that statement is true. Now second one. Every point on the number line is the form of root m, where m is a natural number. That statement is false. What's the reason? No negative number can be the square root of any natural number. No negative number can be the square root of any natural number. We know that there in the number line, what we are marking, that is here 0, 1, 2, etc. This side minus 1, minus 2, etc. For example, if we are taking root of minus 2, we can see no negative number can be the square root of any natural number. Minus 2 is not a natural number. So that statement is wrong. No negative number can be the square root of any natural number. Third statement, every real number is an irrational number. That also false. What is the reason? Every real number is an irrational number. We know that real number contains rational and irrational. So it is not necessary always everything it is supposed to come under irrational. So it can be rational number also. For example, 2 is a rational number. That also coming under real number system. So this statement is false. We can write the reason. Real numbers can be the rational number also. Real numbers can be the rational numbers also. Real number system can be the rational numbers also. So real number contains both rational and irrational. Every real number is an irrational. That statement is wrong. Real number can be rational numbers also. Second question. Are the square root of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Are the square root of all positive integers irrational? No. Why? The square root of all positive integers are not irrational. The square root of all positive integers are not rational. For example, root 4. Square root of 4 will become 2. That number is rational, not irrational, rational. Another example, root 25 is equal to 5 is rational. That means the square root of all positive integers are not irrational. Square root is not irrational. Now third question. Show how root 5 can represent on the number line. For that first we have to draw a number line. And with arrowhead and mark there equal distance in between. If you are taking here 0, you can take any unit, whatever the unit you are taking, take the same everywhere. Now I am taking here 3 centimeter as 1 unit. So this first one 0, 1, 2, 3. 3 units I marked here. And then we can name that as this is O, this is A. Now first we are considering 2 units, and the same way from the point 2 or A, you have to draw a perpendicular. So keep the protractor in the line and mark 90 degree on top. Then take the scale and draw a line on that. Now what we have taken OA, that is 2 units, and to make root 5 we need 1 unit on the top on this line. So take 1 unit in your compass, 0 to 1, same that you have to mark from A to that line, and we can make that as, we can mark that as the letter B. Then join OB. When you are joining O and B, now you can see this is 2 unit, this part we have taken that is just 1 unit. And according to Pythagoras, this is a 90 degree perpendicular. So you are getting a right angle triangle. By Pythagoras theorem, we can write OB square is equal to hypotenuse square is equal to base square plus altitude square. That means OA square plus AB square. We know that OA has 2 units. Till here 1 unit, this one the second unit. So from O to the 2 or OA, that has 2 unit. So we can write as 2 square plus 1 square. It will become 4 plus 1 is equal to 5. That is OB is equal to, OB square is equal to 5, then OB is equal to root 5. So we can mark here that as root 5. Now we got root 5 as OB as root 5. Next we have to represent that root 5 on the number line. For that, from O to B, take the distance OB in your compass and then just mark on the number line. You can mark that point as C and that representing root 5. Now from O till C, OC is equal to root 5. So what we got, that means OC is equal to root 5. The question, how root 5 can represent on the number line. Now we represented root 5 on the number line. Question number 4. It's a classroom activity, constructing the square root spiral. To construct the square root spiral, when just you divide the paper into 4 parts in your mind and mark the origin, just a point on the left top of the paper. Out of that 4 portion, left top of the paper, then only you will get to complete that square root spiral in this paper itself. And also another thing, you can take 1 unit as any measurement. Here I am taking 2 centimeters as 1 unit. If you are taking, your paper is big, chart paper or anything if you are using, you can take that as 3 centimeters also. After that, from P1, OP1, from P1, mark 90 degree, draw a perpendicular line. That also we need actually 2 centimeters, the same unit, 1 unit. We can mark that 1 unit same as that by using the scale till here or by using the compass. Here compass, take 1 unit, here 2 centimeters, so that is 1 unit, and there on the perpendicular line just mark us the same way. So it will come the same. And then join this point, we can mark as P2. Join OP2. Now we know that OP2 means OP2 is equal to square root of this one 1 unit, this also 1 unit. It's a perpendicular line. That means right angle triangle. So we can apply Pythagoras theorem. So base square plus altitude square. 1 square plus altitude square 1 square. That means is equal to root of 1 plus 1 is equal to root 2. That means OP2 is root 2. We can mark that as here. Next part, that is this OP2 as the baseline. Keep your protractor P2 there as the center and OP2 as the base. Mark 90 degree. There also we draw the perpendicular line same way. Here also we need just 2 centimeter. Keep the compass same radius, then it's easy to mark it. And then join with the center. We can mark that as P3. Here it will come root 2 and here 1. We know that root 2 square is 2 plus 1, 3, and this will be root 3. Same way again, continue the same process. OP3 as the baseline and P3 as the center. Keep the protractor, then 90 degree. It is coming here. And join that. There also 2 centimeter same unit. Take the compass. Now you can see that we can mark if you want this as root 1. Then root 1, root 2, root 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. Till root 17 we completed. This is a square root spiral from root 1 to root 17. Everywhere we can mark that as 90 degree. So right angle triangle, if you want you can mark that one. And also for the activity, to make it colorful, you can color it each part with the different colors. So this is the square root spiral activity.